Over 1.5 billion people worldwide suffer from stool-transmitted helminthiasis, or STH. Current diagnostic tools for STH are severely inaccurate and inefficient, making eradication of this disease nearly impossible. That is where we come in.
Hi! We are Paradigm, a biomedical engineering senior design team working with the Children Without Worms initiative at the Task Force for Global Health to develop novel and accurate diagnostic tools for monitoring STH prevalence in developing countries.
1 in 8 people worldwide suffer from STH, a parasitic intestinal disease. These worms are easily transmitted and are especially prevalent among women and children in developing countries. Symptoms of STH commonly include diarrhea, abdominal pain, and malnutrition, with severe cases leading to intestinal obstruction, which can only be treated with surgery.
The current STH diagnostic method, CATO-CATS, has been in use since 1972. The CATO-CATS procedure is performed by lab technicians in developing areas and is not sensitive or consistent enough for the accurate diagnosis of community-wide infection. These issues are due to the fact that the method relies on manual counting of the parasitic eggs, leading to analyst fatigue and inaccuracy given poor egg visibility and human error.
To understand the problem space, we interviewed 15 users with diverse experience levels and expertise, including data scientists, epidemiologists, and even technicians who are out there on the field collecting samples. To address the need for innovation in this space, we developed the ParaViewer. The ParaViewer was inspired by the ViewMaster toy that clicks through different images. Our design, however, utilizes the rotation mechanism to display a number of samples that are plated onto a circular slide adapted with cell imaging chambers. A cell phone camera adapted with a reverse lens is used to produce high-quality magnified images of stool for analysis with an automatic egg counting algorithm.
Our solution produces a fundamental change in how STH diagnosis will be performed. First, the slides will be prepared using a 1-to-1 ratio of stool and saline to homogenize the sample. Next, the 8-well slides will be placed inside the device and the turnkey will be used to rotate the slide. Each channel's depth provides visualization of a single layer of eggs, and this avoids error from eggs overlapping. Next, an image will be taken of each well on the slide using the phone, with any adjustment of the image being done as necessary. Finally, the image stool samples will be analyzed using an automated egg counting algorithm to determine disease intensity and prevalence.
The ParaViewer addresses the needs of current lab technicians by producing a quick, accurate, and easy-to-use tool for assessing STH prevalence. We tested our device with 35 individuals to confirm that our solution can accurately determine infection intensity. While CATO-CATS is unable to differentiate between low, medium, and high level of STH egg intensities, as you can see from these images, the ParaViewer can output clear images of different infection intensities.
Our new slide preparation method averages about 1 minute per 2 slides, whereas the CATO-CATS method averages 4 minutes per 2 slides. Additionally, our device requires significantly less sample processing time than previous methods.
Currently, the worldwide prevalence of intestinal parasitic infection stands at 3.5 billion. While our proposed solution was developed with STH in mind, it is capable of analyzing and diagnosing intestinal parasitic infections in general. As we are able to plate up to 4 samples at a time for a cost of roughly 95 cents per slide, this leads to a TAM of around 3.3 billion USD. Our SAM calculations take into account the STH prevalence of infection worldwide, which is at 1.5 billion, giving us a final number of 1.4 million USD.
Our solution revolutionizes CATO-CATS in several key ways, by implementing an easier sample preparation procedure and having the capacity to image 8 samples at one time. The ParaViewer will decrease technician workload and fatigue. Our solution also removes human error and reading time by producing images that will be analyzed using an egg counting algorithm. The ParaViewer is portable, lightweight, easily transported between different clinics, an important consideration for use in remote, low-resource areas.
Ultimately, this solution will bring accurate and effective diagnosis to over 1.5 billion people worldwide, aiding us in the fight against STH.
Moving forward, we plan to work with the Georgia Tech computer science team to automate slide rotation and develop an algorithm that can automatically detect and count eggs in the images we produce. Prior to implementation of the ParaViewer, we plan to pursue a 510(k) clearance as we seek FDA approval of our Class 2 device.
As previously mentioned, STH Diagnostics has not seen innovation since 1972, and we're excited to bring this paradigm shift to the market.